It is my pleasure to introduce as our next speaker, Professor Ingmar Posner. He's a professor of engineering sciences at Oxford. He runs the Applied Artificial Intelligence Lab and is also deputy director of the Oxford Robotics Lab. Now, let me just say, Ingmar's office looks a lot more interesting than mine. The first time I went there, it was wonderful. It was just like walking onto a Star Wars set where there are lots of generations of drones, and that's what he does. In fact, Ingmar pointed to one vehicle and said that's Mars lunar landing vehicle. So Ingmar is a deep thinker in the area of AI. He's a pioneer in machine learning, both on the foundational side and on the applied research side. He's got a special interest in especially autonomous driving, also logistics, space exploration. And Ingmar is somebody who spans both academia and entrepreneurship because in addition to his academic work, he's the founder of Oxbotica, started in 2014, already a leader in mobile autonomy software. Some excitement recently about a commercial partnership with Ocado on self-driving food delivery solutions. And Oxbotica has the modest ambition of bringing us universal autonomy. So we're very much looking forward to hearing from Professor Ingmar Posner.
Thomas, thank you so much. Wow, what an intro. Okay, thanks for inviting me to speak. Where to start? Deep learning has a data problem. And when it comes to this audience right here, that actually is an excellent thing, right? Because it means first there are things to be improved about deep learning, but also because it has given rise to a tried and tested model for startup success. Get your hands on unusual data, deploy increasingly commoditized machine learning technology, and then improve your product. And the flywheel effect then basically implies that a better product leads to broader deployments, these beget more data, which in turn then allows you to further improve your product and so on. And this virtuous cycle is, of course, the reason why data is more precious than gold at the moment. And we see this right here in CDL as well, right? So machine learning technology continues to be commoditized, proof of concept becomes easier, scaling remains difficult, but it's becoming easier. And as a result, the ventures we see come through CDL are often innovative in their application focus, but to date only rarely really advance ML technology itself. It also highlights that your real first mover advantage as a new venture in the AI stream lies in securing access to unusual data. That is often where the value lies. Now, why am I telling you all this? Well, because even though it has served us well so far, this data flywheel is really in the process of being disrupted. There are at least two recent trends in machine learning that are both accelerating and broadening access to data. Firstly, being able to learn complex machine learning models means there exists a huge opportunity in exploiting our system infrastructure to generate complex data sets. So in particular, there is an increasing trend towards what I call system-level self-supervision, where supervisory signals for complex learning tasks are derived extremely cheaply directly from operating the system. And in the context of autonomous driving, for example, we've been exceptionally successful in the past in deriving training labels indicating where humans tend to drive across a whole range of scenarios. What's important is that these come entirely free because of the systems engineering that has gone into it. Similarly, we often see this sort of approach used when it comes to one sensing modality informing another, or when it comes to learning performance predictors that help making deployed systems more robust, etc. And interestingly, AlphaGo and its derivatives are excellent examples of this happening. So it's exciting because it really accelerates the building of product capability at a very, very low overhead. The second opportunity that has arisen lately provides a beautiful extension to this notion of self-supervision, and that's the ability to generate or imagine your own training data based on unsupervised learning of generative models. Data augmentation, of course, has been a thing for decades, but typically this is based on simple transformations of the original data. But recent advances in deep generative models have really strapped rocket boosters to this notion. So the ability to synthesize complex but realistic data streams for almost any scenario, any sensing modality, any application domain is really disruptive. Yes, this is the technology that also has given rise to deepfakes, true, but it actually means you no longer have to have a vast deployment infrastructure to gather all the data you need to get going. For example, we can use this sort of tech to synthesize realistic radar data based in common driving simulators. And of course, others like Google and Waymo are exploring it to generate sensor data for various environmental conditions and so on. If you're not convinced, just think of the impact of models such as GPT-3 or WaveNet in the context of language modeling and speech synthesis. Now, don't let me overegg this. Currently, this works for some cases, but not others. There's quite a bit of research that still needs to be done to make this universally useful. But for people like me, of course, that is where the fun lies, right? So at the intersection between pushing the state of the art in AI technology on one hand and creating something that is useful and of commercial value. Okay, inevitably, what I've talked about is sort of a super subjective set of trends that I believe provide commercial opportunity. This space is where I spend most of my day job, so I can't help being excited about it. But I do hope you also find some inspiration here and enjoy the rest of the day with the many exciting ventures here at CDL. Thanks.